Hello guys, welcome to my next lecture of probability and statistics. Today we will see about Bernoulli distribution, then binomial random variable, then Poisson distribution and some of its examples. So this lecture would be very much beneficial for people who are studying in MSc or BSc in mathematics or data science. Also, if you are preparing for GATE or any competitive exams which has statistics and probability in it, it's very much helpful. It's actually the notes of MSc level. So let's get started. First of all, let us know what is Bernoulli distribution. What is the definition? A Bernoulli random variable takes two values 0 and 1 with probability 1 minus p and p respectively. If the random variable has value 0, then its probability associated with it is 1 minus p, and if the random variable value is 1, its probability is p. The probability mass function of Bernoulli random variable is p is from r to 0 to 1. Okay, so p of x, if x is 0, then its probability is 1 minus p. If x is 1, its probability is p, otherwise it is 0. The distribution function of Bernoulli random variable f from r to 0 to 1. So if x is less than 0, the distribution function f of x is 0. If it is between 0 and 1, where 0 is included but 1 is not included, 1 is excluded, f of x is 1 minus p. And if x is less than equal to 1, then f of x is 0 plus 1 minus p plus p, which is 1. And if x is greater than 1, f of x is equal to 1. Now binomial random variable. Repeat n independent experiments, each of which has two outcomes with probabilities p and 1 minus p. The outcome with probability p we will call as a success, and with probability 1 minus p we call it failure, or we can take q also, but since the sum of total probabilities is 1, for our convenience we are taking p and 1 minus p. Here there is two cases only, success and failure, that is why. So let the random variable x denote the number of successes in these n trial. Okay, so the PMF of x is p of k equal to p of x equal to k, which is nck p to the power k 1 minus p to the power n minus k. If there are k success and n is the total number of trial, then there is n minus k number of failures. For example, we will take an example that suppose we have x equal to 2. That is, we have 2 success. For n is equal to 3, we have 3 number of trials and we are getting 2 successes. So there may be 3 cases. Okay, first there could be success, then failure, then success, failure, success, then failure, success. Okay, if probability is success, failure, it would be p square multiplied by 1 minus p. If success, failure, success, p square 1 minus p. If failure, success, p square 1 minus p. Okay, since there are 3 cases, we will multiply it with 3 into p square multiplied by 1 minus p. So in general we get 3c2 p square 1 minus p 3 minus 2, which is to the power 1. This means nck p to the power k 1 minus p to the power n minus k. Okay, I hope you understood this. Now, Poisson distribution from binomial distribution. Okay, the probability mass function of a Poisson distribution with parameter lambda greater than 0 is defined by P of x equal to k is equal to lambda to the power k by k factorial multiplied by e to the power minus lambda, where k is 0, 1, 2, so on. Okay, so it is a generalization of binomial distribution with np equal to lambda and n tends to infinite. So when we increase n gradually, it decreases p, which makes the product constant and gives rise to Poisson distribution. Let us see the proof. We have the binomial distribution as nck p to the power k 1 minus p to the power n minus k. We can write nck as n factorial by k factorial multiplied by n minus k factorial, p to the power k 1 minus n to the power k. Now, in place of p, we can substitute lambda by n. So here n factorial by k factorial multiplied by n minus k factorial multiplied by lambda by n to the power k, and here again 1 minus lambda by n to the power n minus k. We are taking lambda k and k factorial together, then n factorial by n minus k factorial multiplied by n to the power k. We can write 1 minus lambda by n minus k as 1 minus lambda by n to the power n multiplied by 1 minus lambda by n to the power minus k. Okay, it's fine, right? Lambda to the power k by k factorial. Now we have n minus k factorial and here we have n factorial. While dividing, we will get n minus k plus 1, n minus k plus 2, so on n by nk. Okay, here what had happened, suppose we have 5 factorial divided by 3 factorial, for example, then what we do, 5 multiplied by 4 multiplied by 3 factorial by 3 factorial, 3 factorial and 3 factorial gets cancelled, we have 5 into 4. Similarly here what had happened, that if n minus k factorial, we have written this as n minus k n minus n, n minus 1, n minus 2, so on, n minus k plus 1, n minus k plus 2, so on, n minus k. So n minus k factorial gets cancelled. Then we have n minus k plus 1, so on, n by n to the power k. Okay. Then 1 minus lambda by n to the power n multiplied by 1 minus lambda by n to the power minus k. Now we have lambda k by k factorial, n minus k plus 1 by n, n minus k plus 2 by n, so on n by n. Here it is k times. So 1 minus lambda by n to the power n multiplied by 1 minus lambda by n to the power minus k. So here it is n to the power k, so this is k times. Okay, here what we have done, that we have divided it. We get lambda k by k factorial. This is 1 minus k minus 1 by n, because minus gets common, then the plus become minus. Okay, so similarly 1 minus k minus 2 by n, so on 1 minus lambda by n to the power n. This is 1 minus lambda by n to the power minus k. Now what happened is that as n tends to infinite, all this denominator, all these terms becomes 0. Okay, 1 by infinite is 0. Now at this place we will explain this. 1 minus lambda by n to the power n, when n tends to infinite, becomes e to the power minus lambda. How? Okay, by the definition of calculus, we have limit n tends to infinite 1 plus 1 by n to the power n as e. Okay, now if we have x in place of the numerator, then the definition become a limit n tends to infinite 1 plus x by n to the power n becomes e to the power x. So substituting minus lambda at the place of x, we have limit n tends to infinite 1 plus minus lambda by n to the power n, which is e to the power minus lambda. So this part, when n tends to infinite, becomes e to the power minus lambda, and this part again, this is 0, so 1 to the power minus k, which is 1. So substituting the final results, lambda k by k factorial multiplied by 1, so on n times, which is k times, sorry, which is already 1, e to the power minus lambda, and this is 1. We get lambda k by k factorial e to the power minus lambda, which is the Poisson distribution. So let's do a small example actually. After that we can wrap up and we will continue in the next video. Okay, so there is an example, there is a question. The following table shows the cumulative distribution function of a discrete random variable. Find the frequency function. Okay, we have the k values and we have the cumulative distribution function. Okay, we have to find the frequency function. So we have given that x is a discrete random variable. So given x is a discrete random variable with f of x, if x is 0, f of k is f of x is 0, if x is 1, f of x is 0.1, if x is 2, f of x is 0.3, if x is 3, f of x is 0.7, if f of x if 4, x is 4, f of x is 0.8, and if x is 5, f of x is 1. So the probability or frequency at x equal to k is the difference of the cumulative distribution function f of k at x equal to k and previous point f of k minus 1. So p of x equal to 0 is f of 0, which is 0. P of x equal to 1 is f of 1 minus f of 0, which is 0.1 minus 0, which is it's actually which is 0.1. Then p of x equal to 2 is f of 2 minus f of 1, 0.3 minus 0.1, which is 0.22. Then p of x equal to 3 is f of 3 minus f of 2, which is 0.7 minus 0.3, which is 0.4. P of x equal to 4, f of 4 minus f of 3, which is 0.8 minus 0.7, 0.1. P of x equal to 5, which is f of 5 minus f of 4, 1 minus 0.8, which is 0.2. So combining this information, we then obtain the frequency distribution. For x equal to 0, we have 0. For x equal to 1, we have 0.1. X equal to 2, we have 0.2. X equal to 3, 0.4. X equal to 4, 0.1. X equal to 5, 0.2. Okay, I think it's enough for today's class. If there is any doubt, you can ask me in the comment section. Please like, share and subscribe if any of your friends needs it. Thank you. We will meet you in the next video.